download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about the history of the atom. Now our ideas and our theories of the atom have massively changed over time. The first scientist to really start talking about the atom was a guy named John Dalton. Now he described the atom as a solid sphere. So imagine a snooker ball, but obviously much smaller. That was our original thoughts from a science perspective on what the atom looked like. Okay, so just trying to draw on that, kind of just like a solid sphere. Now then a scientist called J.J. Thomson came along, and he concluded from his experiments that actually the atom could not be a solid sphere. And his experiments showed that the atom must contain something even smaller within it. So he came up with something he called the plum pudding model. Now what this model showed is he had a ball of positive charge, so much like John Dalton's sphere. However, this was positive, but there was also electrons or negatively charged particles stuck within it. Okay, so it can be described as a ball of positive charge with electrons stuck in it. And he called this the plum pudding model because essentially it looks like a plum pudding. Now, a bit later on, a scientist called Rutherford came along. Okay, now Rutherford came along and did something called an alpha scattering experiment. So an alpha scattering experiment. So this is where they took a piece of gold, a very thin piece of gold foil, and they fired positively charged alpha particles at an extremely thin sheet of foil. Okay, so they had alpha particles, which is a helium nuclei, so essentially it's made up of 2 protons and 2 neutrons, and they fired these particles at the thin, very thin piece of gold foil. Now, they were really, because looking at the plum pudding model, expecting a lot of these particles to just go straight through them, because if you look at the plum pudding model, then mostly it is empty space. This was because the positive charge of each atom was thought to be very spread out, i.e. mostly empty space. But most of the particles did go straight through, which showed that most of the atom was empty. However, some were deflected more than expected, and actually some were deflected straight backwards. So like here we're firing the gold or the helium nuclei or the alpha particle at the gold foil, it deflected straight backwards. Now this led Rutherford to come up with the idea that there must be a tiny positive charged nucleus at the centre of an atom. So this led him to essentially come up with something called the nuclear model, where he still had his ball and he still had his negatively charged particles spread out within that ball. However, there was a much more dense positive nucleus in the centre of that atom. And this was called the nuclear model. So he essentially, firing the alpha particles at this model, most would go through, because if you look, most of it is empty space. Sometimes they would deflect off this way, and that's when they'd hit a electron or a negatively charged particle, but sometimes they would deflect straight back, and that is when it must have hit that very dense positive nucleus in the middle. So they called that the nuclear model. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, another scientist called Niels Bohr then came along and actually thought that, well, actually, if the electrons, if it's a cloud of electrons around the positive nucleus, then surely the atom would collapse in on itself. And that didn't make sense to Niels Bohr. So he then suggested a second nuclear model where actually there was a positive nucleus in the centre, but then the electrons, the negatively charged particles, actually orbited around that nucleus in shells or energy levels. Okay, so we can call this the planetary model. And this was discovered, of course, by Niels Bohr. And he did many, many experiments. Now, if you look at this model, this is very, very similar to the model that we have today. There were just a few additions that came along. So Rutherford, again, in future experiments, sort of found out and discovered the proton. And that the proton must exist within the positive nucleus of the atom. So that he discovered the positive charged protons. And then about 20 years later, a guy called James Chadwick came along and he discovered the neutron. So his experiments led him to discover that the nucleus wasn't just made up of positive protons, because again it might just collapse in on itself, but also it was made up of neutrally charged neutrons as well. So as you can see, there's lots of changes in how our ideas of the model of the atom has changed over time, and that really goes with everything in science, how ideas change all the time. Started off with just a solid sphere from John Dalton, then J.J. Thomson said, well, actually no, it's more like the plum pudding model. Rutherford did his alpha scattering experiment. He sort of developed the nuclear model. Niels Bohr came along and just added the energy levels, the energy shells. Then Rutherford discovered the proton, and then James Chadwick discovered the neutron. And then it sort of led us to what we believe today to be the atom. So there's the history of the atom. What I would now like you to have a go at is trying to answer these 5 questions here. And we'll go through the answers after. So pause the video now. Okay, so question 1. Describe the plum pudding model. Okay, well, the plum pudding model can essentially be described as a ball of positive charge with electrons spread out. And that is a good descriptor, really, of the plum pudding model, and obviously discovered by J.J. Thomson. Number 2, outline Rutherford's scattering experiment. Well, a very short outline is that he fired alpha particles at a thin gold sheet. 3, explain what conclusions could be drawn from the Rutherford experiment. Well, really, there was 3 main conclusions. 1, most of the alpha particles went straight through, which sort of agreed with the idea of Thomson that most of the atom was empty space. Some of the alpha particles deflected slightly, and this led to his conclusion of the existence of those electrons around the nucleus. And the third one, which was really the big addition to the model, was that some alpha particles deflected straight back, which led him to conclude that there must be a dense positive nucleus in the centre of the atom. What did John Dalton say the atom looked like? A solid sphere. And finally, what did James Chadwick discover? He discovered the neutron. So I hope all those questions were okay for you and that you really understood today's topic. You can now use the quiz and the exam questions to really start testing yourself and embedding that knowledge. If there's anything you didn't understand in this particular experiment, then please do get into contact with one of our tutors and they will be happy to help.